So, after considering the performance limitations of the neodymium magnet and the coil configuration on a 12-volt system, we came across the idea of adding, we're going to keep the, let's see, the balance beam, with the 25-pound weight. We'll have 5 of them on a, on the at the pivot point, and then over here we'll add a paddle wheel driven by a small DC motor. We'll have the rack and pinion, with the gear train, and the PMA at the output, and so it'll be like 12 volts, 3 amps, and then we'll attempt to generate as much electricity at the output as possible. This configuration will have no large neodymium magnets or pendulums. And then let's see what else. Because there's 5 balance beams, the paddle wheel, this is a side view. Essentially, it'll be in a helix configuration, so that as it rotates, it'll push down on one of the 5 balance beams, release it, push down on the next, release it, push down on the next, release it, and it'll cycle. So 1 through 5, 1 through 5, 1 through 5. And that'll create a condition where there's, approximately 100 pounds falling at all times to drive the rack and pinion, gear train, and the PMA. So we're going to call this project hammerFall. Basically, the frame and everything has been built, and I don't know if you can see that or not, but all the parts have been designed, and we'll post results when available. Small DC motor at the input will be constantly on. So I ordered a 12-volt geared right-angled gear motor. I'm not sure how much current it'll draw. I know I can use a windshield wiper motor that draws, approximately 3.5 amps at 12 volts, and we can also use a pulse width modulator to slow down the the RPM. So let's this is doable. I should be able to fabricate it relatively quickly, and then we can test the 3 permanent magnet alternators that we have. So Project hammerFall, yeah. Enjoy the day. Hope everybody's staying cool. Check out the example video for a better explanation of how this will work. So thanks for watching. Cheers.